Newton's second law is best summarized by an equation. But if we want to describe it using words, acceleration of an object is increased by either increasing the net force on the object or by decreasing the mass of the object. So we can rearrange this equation. If we want to increase the acceleration, we could either increase the force, which is the numerator, or decrease the denominator, which is the mass. So we can accelerate something quite a bit if it's either very light or if we push it very hard. So one thing to keep in mind when we say this acceleration, and it mentioned it on the other slide, it's the net acceleration. And what that means is that is the acceleration we will observe the object to have. We will be able to observe that acceleration. This is important if we have an object that is falling. So if we have an object that is falling, it's being pulled by the force of gravity downwards. And if that's the only force it has, then we will observe an acceleration that is 9.8 meters per second per second. So every second that it's falling, it'll fall somewhere around 9.8 meters per second faster every second that it falls. However, now that we're talking about forces, we can kind of start talking about how air resistance influences how our objects fall. So if we have air resistance, we will not observe the object to be falling with that acceleration anymore. If we have air resistance, eventually it won't accelerate at all, especially if it's a very light object, such as a feather. So the reason we see feathers kind of float gently to the ground is because it's not accelerating at 9.8 meters per second. Net force and acceleration, the net acceleration, will have the same direction, and we also mentioned this before. If we have an object falling towards the ground, it's being pulled by the force of gravity, and its acceleration is also downwards. And then the next thing we need to mention is that force will be measured in a unit we call a Newton, after Isaac Newton. So force is going to be a kind of a combined unit. It's a unit that we make up of several other units. So if we take mass has a unit of kilograms. And acceleration has a unit of meter per second squared. But because that unit comes up so often, scientists have decided that we should call that unit a Newton. But sometimes this gets a little weird. If you divide force by mass, you don't get a Newton divided by a kilogram. Instead, your unit will be the unit for acceleration, which is meters per second squared. And like I said, it's because we've combined all these units, wrapped them up into one thing, and we called it a Newton. So this is another place where you should be careful with what units you're dealing with.